talking about the agenda of today's session, it is basically reporting of the statistical results is one key component of quantitative research. This will help you learn simple rules for effective statistical practice, statistical issues in non-statistics research articles, and effectively report statistical results and in various sections of the research reports like in abstract, introduction, discussion, and conclusions. So over to you, Dr. Sharoon. I will share your PowerPoint.
Sure, great. In the meantime, if I'm able to join it from a computer, I'll just switch on to that so that I can control the presentations for myself. Right?
Sure, sir.
So,
PDF files. Is my screen visible? Yeah.
yes. So hello, everyone. Sorry for this inconvenience. It's certainly I have two laptops and both had like this window update started. So in fact, one had the Zoom's update started as well. So I'm unable to join in from there, but thank you so much, Kohar, for this quick response to it. And we were able to join get these slides up. Today, I want to talk about the presentation of the research results, and mainly my goal is to talk about how to present your statistical results in the form of your research articles. So, if we talk about the science, then what I have learned that it is very political, it's competitive, and fears a career. I mean, a lot of you must have been already in academia and must have been experiencing, a lot of challenges there as well. And I mean, we live in Pakistan, where our even in the faculty, our promotion criteria are based upon the number of publications. So sometimes it's I mean, doing research is great, but sometimes it's really hard to put all those things together and sum them up into one article. And this is writing is sometimes one of the hardest tasks that we have to perform as a researcher. So go to the next, please. So this path that you follow of doing research is very tempting. You will get a lot of opportunities where you can, fake your data, where you can create your data at your own computer instead of really doing the experiments or going to get a survey and finding rather easier ways to publish. But, it's not how it should be. Your point of doing research is not only to make other professionals in the academics happy, but you really want to learn about the phenomena that is under study by you. So it's not about others, but it's about yourself as a researcher. And a researcher should have a keen interest into what they are doing. So you really want to know more about the phenomena that you are studying, and as you keep knowing about each one, you keep growing your knowledge into it. And that's how we take small steps into the research to to know more about something. So so one of the biggest challenges that have been reported in the past is the crisis of irreproducibility. So, it has been observed that there's a research that has been produced by one organization in one lab, and they are unable to produce their own research, like by the same researcher, same instruments being used, same person is doing the research, but they are unable to reproduce their own results. So, there has been this crisis that science is dealing with. And right now we are talking about artificial intelligence, and so many other new avenues are opening up to do research. One of the problems that we are facing with this is that, while we write our codes, our codes are irreproducible. I mean, sometimes we look at our own written codes and we are unable to figure out that what exactly we were doing. So if you are into the computational sciences, we prefer to write our codes, and especially when you're talking about the data analysis, when you're writing codes to perform your data analysis, I personally always recommend individuals to always write the comments along with the codes so that your code is reproducible. Someone can understand your code, and sometimes it always happens with the writings that we are unable to remember that why we are writing some codes and why we are writing something. So there was a study in 2015 that looked at 83 highly cited studies that claimed that to feature effective psychiatric treatments, and they found out that 16 had ever been successfully replicated, and 16 were contradicted by follow-up attempts. So they were not being able to reproduce the same results, and 11 were found to have substantially smaller effects that second time around, and nearly half of the studies had never been subject to replication at all. So I understand, and I've shared it in my earlier talk as well, that I've seen people talking about it that, oh, well, what new you have done in your research. Please know this, research is not always finding new, but research is also about confirming the existing theory, because when we deal with this crisis of irreproducibility, then it gets harder for us to report our results. So the other challenge that we face is go to the next slide, please, is that science is poorly communicated. It's you see this, you will always get to see results, people talking about that, I'm giving a very novel technique, or my idea is unique. People use these kind of words quite a lot, which are redundant. These words are great to hear, but they are not something that portrays the real picture. And I do remember this one paper earlier, long ago, that actually talked about that how people have written non-significant statistical results as significant. So, or they use the language in a way that people will think that their results are significant. So they talked about like 100 different ways people have reported non-significant results, because they don't want to write negative words. It's sometimes people find that if they write non-significant results, it means that they failed the experiment. But that's not what's it is true. And that's, as a scientist, we shouldn't really follow this kind of gimmick, because it's very important that you communicate what's out there. If your results are negative, please report the negative results. If your results are positive, please report the positive results. Like you see in this chart, there's a gray line that talk about that how many people use the word novel to just make their research sound more newer, more appropriate. So this is one of the challenge that we are facing right now, that the whole scientific literature is filled with these kind of positive words where you always want to look for the significant results. But please know this, reporting non-significant results is also important, because if We are just reporting something that has already been known, that has already been positive, and you are not presenting a contradictory statement to it when it can possibly be done on different population. Then you're not really doing the science, but you are just confirming the existing results and trying to make your colleagues happy. But this is not what science is about. So one should really be careful while they report their scientific results, that they should be reported the way they are. Now, here's a challenge. When we are doing scientific research, we actually have so much tasks that we have done. We get so many things that we have done in the middle. So you have to sum up into one or two or three or four pages of your scientific research paper. So you must have seen that your thesis sometimes goes to 40 pages or 100 pages or even more. But your research article doesn't require you this much. Your research article requires you to write less. So, you always come up with a question, concern that, oh, well, I have 76,543 pages of research findings. But the key is how to report it. Can you go to the next slide, please? Now, the trick here is to let your creativity flow and let your storytelling skills shine. As a researcher, and especially when we are reporting researchers, we don't really act as like a scientist that we generally know of. Please know this, a good scientific writers are good storytellers as well. So while you're writing your research articles and reporting your results, you have to act like a storyteller, where you have to summarize 75,000 words or 75,000 findings into just very few, let's say into 1,000 findings. So you really have to be very smart while you're doing this. And that depends how good storyteller you are. So here are some tips that I want to give while you present your research data. There is a first rule that keep it simple. Because if you can't explain it simply, you cannot understand it enough. So this is one of the challenge. So I've done it with my students here as well, that I give them to write their research or write what they want to write their projects in shortest words, a number of words, and that's the challenge they always find, that they are unable to write abstract in less than 500 words. They're unable to write the introduction section into 1,000 words. So it's very crucial, it's very important that we write things in a more precise way. And the key is that you keep it simple, because it's like you don't really have to reinvent the wheel. It's not about reinventing the wheel. You already have like 10 commandments, so just do the 10 commandment instead of talking about 8,675 different rules that you, or these many results that you have found. You always try to report the important ones, the significant ones. Go to the next slide, please. And the second rule is that be specific. When you start writing your paper, you start with your response rate and description of the participants. And please know this, here my focus is reporting the statistical results. So I'm talking about the statistical portions and the results section only right now. So while you report this, you always start with the response rate and description of the participants. I have seen it a number of times. Response rate is never shared in the research articles. The description of the participants is hardly discussed. So it's very important that what is your target population, you describe them. And then you talk about your key findings and relevant statistical analysis. You don't need to write every single finding that you have found in your research. You have to be very selective while you do this, and very specific, that is in line with your research topic. So, the third rule is the data should answer the research question identified earlier. Right now, we understand data is a new oil. Data is the most abundant element in the social goods sector. Right now, you talk about Facebook, you talk about Google, you talk about Twitter, all those big tech joints. They are earning money out of the data that we provide them all the time, right? So I often do this exercise in my classes that, and you can try this after the session is over, that you just simply keep your phone besides you and you don't have to touch it, keep it on the sleep mode, and then talk about something for 5 minutes around it. Let's talk about some shoes, maybe talk about something, and open up your social media right away. You will see, and I'm not talking about only Facebook. I'm talking about Instagram. I'm talking about Twitter. I'm talking about other social media platforms as well. They will show you all the ads about the shoes. If you talk about furniture, they will show you the ads for the furniture. Why? And that's how fast they're using your data. So data is that abundant right now, and people are using a lot of data. But the key is that it's your data that should answer the question. I've seen a lot of times people have collected the data for something else, and they try to put in their own thoughts into it, which are not coming from the data. So it's the data that should answer the question. And it's not something that your question should lead to the data, but your data should help you answer the question. So a lot of people, once they are unable to find the answer, they try to play around with the data and try to change the data accordingly. That's a crime. That's not a right way to do research, and that's not the right way to report the research as well, because now your data has been fudged and it's not something that's important, and that should be justified. The rule number 4 is that leave the process of data collection to the method section while you're writing. Your data collection methodology should be written in the method section, and please do not include any discussion in there into the method section. All the discussion regarding your data, regarding your results, should go into your discussion section. In your method section, you simply should talk about your data collection methods and some other methods aspects of it. The rule number 5 is that use the past tense. That while you're writing and you're describing, you use the past tense, because your research has already been done and now you are just reporting your research. Then there's a rule number 6. When you have a lot of text, you have tables and graphs. Now this is something very important. I have seen that in the research articles, people are reporting one and the same thing in the text, in the tables, and the graphs, all 3 formats. No, you have to be very selective that how do you report your results. And tables, texts are great, but sometimes graphs can carry a whole lot of information. Tables are good. A lot of people are really good at reading tables, so they can infer quite well and quite fast from the tables. And the text written is great. It explains, it does carry some input from the researcher as well, or the text should contain the items that a researcher thinks that are very important to highlight. Those should be reported in the text, but rest of the data can go into the table. But keep that in mind. Something that is reported in the text may not require to be reported in the tables and the graphs. So don't repeat the same information in more than one format. If you have reported it in the table, don't report it in the graphics until or unless that is something that is coming from your primary hypothesis. The results from the primary hypothesis may or may not be reported in all 3 formats, but please, if there's anything else other than the primary research question, primary hypothesis, that should be reported in one of these formats. And then there's while you're reporting the text, you have to be very precise. So I have given you this example here that where it says that mean baseline HbA1c of 73 diabetic patients before intervention was 8.9% and mean HbA1c after intervention was 7.8. So here's the problem with the first statement. You can write the statement by not repeating mean HbA1c before and after the treatment and just reporting it. But if you see the statement given in the point 2, that is much more summarized, that mean HbA1c of 73 diabetic patient decreased from 8.9 to 7.8 after an intervention. So you see this, that is one way. I mean, this is the one of the challenge actually I've seen, that they have so many results and people find it hard, and I also deal with all the challenge all the time, that we find it hard to put or squeeze every single thing into one research article. And scientific research papers, journals, they ask for a very small number of a very less number of pages for your research articles. And sometimes if you submit your article into the paid journals, they ask for more money. But right now, one other thing that you can do is, if you have so many results, you can always create supplementary tables. And journals are often now creating links to the supplementary tables for your article. So in the research paper, you report some of them, but rest of the results can go into the rest of the tables can go into the supplementary material. So always make use of the supplementary material to report your lot of information out. But in the research article, when you are writing your results section, you have to be very precise so that you can save as much space as you can. Go to the next, please. Can keep one thing in mind, that data which often are numbers and figures are better presented in tables and graphs, where the interpretation are better stated in text. So this is the key. You have to be very clear that interpretation is something that should be shared in the text. So however, if there are too few variables, the data can easily be described in a simple sentence, like, for example, the majority of diabetic patients enrolled in the study were male, and you simply report the number right there, 80% compared to the female, 20%, right? This instead of writing a statement that how many percent were the females and how many percent were the males, you simply put the numbers into the brackets, and that suffice. That reports the same results the way you want to do it. There's something more to reporting the text, that using qualitative words. Go to the next slide, please. Using qualitative words to attract the reader's attention is sometimes not helpful. Like you use a term like remarkable, decreased, extremely different, obviously higher. These are the redundant words. So it's better that you use exact values in the data. Right? So avoid redundant words and information. Do not repeat the results within the text, tables, and figures, and only important points and results need to be highlighted in the text. Keep that in mind. Only important points and results need to be highlighted in the text. Next slide, please. Now I'm going to talk about the reporting of the results in the table. Always keep it in mind. Next slide, please. Always keep it in mind that your table should carry a title that explains, and title should be written very, very carefully. You always need to put some thought into it, that how do you write the title of the table. Every table should be numbered. Every table should be numbered, and whenever you talk about this table, you always write that number there. And know this, that there are columns and rows in there. So we can list the dependent variables in the first left column and independent variables across the top. Or you can do it otherwise. You can put the dependent variable on the column and all the independent variable on the row side. So you can do that. But you need to make sure that you cut down unnecessary column, which can be replaced by footnotes explaining their definitions. Like you can see a lot of symbols are here in this table. Like there is a static sign, and a static signs is for WC. There's a waist circumference. So you can always make use of these footnotes for the tables, where you can actually save the space as well in the table. Instead of writing waist circumference in the first column, you can simply write WC and put the star next to it. And similarly, we do the same when we are talking about that what tests one has used, or whether the value is significant or not. We can use this by reporting the results over here. Go to the next slide, please. So for example, we can eliminate the columns on P values in the table when you perform a student t-test or the chi-square values. So look at the table 2, where you are given just the odd ratios, and there are these asterisk signs, there are these symbols next to it, which shows that the odd ratios with 95% confidence intervals are given, and these odd ratios are given, so their p-values are given. So keep one thing in mind while reporting statistical results: either you report confidence interval or you report the p-value. If you're generally, people talk about the p-values to be reported, but I personally think that it's not always the best idea. Confidence intervals sometimes give us a much better insight into the values, but I mean, if statistics enough, you can still infer using the confidence interval. You can still infer whether to reject the null hypothesis or do not reject the null hypothesis. But this is something that's very important, that how you present the result. But you can always make use of these asterisks, these pound signs or different symbols out there to reduce the size of your tables. Next, when you're talking about the body of tables, you arrange date and timing from left to right. Keep that in mind. You should be consistent in use of units and its decimal places. Always report the units of the variables. And one more thing, while you are reporting your results, you round off the numbers to the fewest decimal places and keep the same thing throughout your research article. If you have values written as 2.2, then all the values should be written at 1 decimal place. You can't just do one as values 2.2 and other is 3.78. So if you want to do 3.78, you should instead write 3.8 instead of writing 3.78, because you want to make a rule that, okay, I'm going to report all the values at 1 decimal place, 2 decimal place, 3 decimal place, or no decimal place. But that's solely the decision of a researcher or the statistician that are working with them. They can guide them that what's the best way to do this. Generally, statisticians think that reporting it for up to the 4 values is fine, 4 decimal places is fine, but that's not always the good idea, because 4 decimal places sometimes take too long of us, too wider of the space, and you really want to avoid save the space, and you want to avoid too many lines in a table. If your table is pretty big, please report it as a supplementary table. Don't put it into your research article. Your research article should contain a very smaller tables, very concise information, your graphs that are more explicit to your hypothesis picture. You can always look at the more trending graphs that you have, so you can always make use of those graphs. And every research, if you're reading the recent research articles, you should be able to see the more recent type of graphs people are reporting in your research area to report the similar kind of results. So make sure that you report it in the same type of way. So while you're doing the graphics, you got to be clear on the question that how will the visualization help the reader? You have to think about it. You have to ask this question from yourself. And another thing, that know your data and start with basic visualization. I've seen people going with a very complex statistical analysis and complex visualization, and they think that they're doing a very difficult type of statistics, so their research paper is really good. A lot of people don't get really impressed with the difficult statistical analysis that you have performed, a very complex visualization you have presented. Please know this, that your chart should be attractive, but it should be informative as well. And start with a basic visualization, a simple graphs, and then go ahead. You should have to decide what goes onto the x-axis and what goes onto the y-axis. Does the size of the data points mean anything? Does the color of the chart mean anything? Are we trying to identify trends over the correlation? You really need to talk about it and use color, size, scale, shape, and labels to direct attention to the key message. right? Then there are bar charts. So while you're constructing the various charts, bar chart is one of the very commonly used type of charts in sciences as well as social sciences. I've seen that. So either horizontal or vertical are used to display categorical data. So know this, bar charts are most of the time are used to simple bar charts are used to report categorical data. But if you have quantitative variables, you can use histograms to report your results, right? Sometimes we can use multiple bar charts to report our results. So strictly speaking, bar charts with continuous data should be drawn as histograms and line graphs. And usually data presented in bar charts are better illustrated in tables. So you really want to save your space on this by presenting these results in the table. And then one more important thing is, yeah, 3D graphs are very much in. Animated graphs are very much in today. A lot of people are proud to do that, but please know this, that research articles, unless they're available online, reporting 3D graphs sometimes doesn't make sense because 3D graphs need to be interactive. So you really need to have a computer. If you're reading it on the paper, you can't really do the interaction with the graphs. So that's something very important here. There are some guidelines which are available there that you can do. Earlier in one of my talk, I've talked about different type of study design. So you can always make use of Strobe guidelines while you write the paper. If your study design is case control study design, go for the Strobe guidelines for case control study design. If you have a cohort study, go for the guidelines for the Strobe guidelines for the uh, cohort studies. Similarly, there are guidelines for reporting experimental studies. There are guidelines for reporting clinical trials as well. There are guidelines for reporting systematic reviews. So you can always follow these guidelines. And if you follow those Strobe guidelines, you will see that what ingredients should be added into the article and where they should go. And you should be following a very standard protocols which generally are acceptable into the scientific community out there. So next, I want to talk about 10 simple rules for effective statistical practice, which are very important. The first rule is that statistical methods should enable data to answer scientific questions. Please don't play with the data. Instead, your statistical methods and data should answer the question. It shouldn't be the other way around. The rule 2 is that signal always come with noise. Keep one thing in mind, that signal always come with noise. So, that's very important that you know this, that uh, there's always error along with it. So while you deal with it, make sure that you actually talk about the error and use right statistical methodology to do this. Rule 3 is that plan ahead, really ahead. Uh, while you're writing your synopsis, while you are, in the usually quantitative methods are done in the quantitative research, and when in the quantitative research you spend a lot more time in the planning, in uh, you know in the planning of your research. So it's very important that you talk about your statistical methods, your statistical presentation of the statistical results at the time of your planning, so that you are aware that how you want to report. A lot of research, especially in the clinical trials, we always write statistical analysis plans. So always try to have a statistical analysis plan while you do your research. And then there's a rule 4, that worry about the data quality. A lot of people don't really care about the quality of the data. So you really need to worry about the quality of the data. Your data should not have a lot of missingness. Your data should not have a lot of outliers. Yeah, outliers are great. They are the point that can give you the Nobel Prize. But you know, they should be legitimate outliers, not just like the typos or the outliers which are present because of some errors in your data collection methodology. So you really need to worry about your data quality, and data quality can be ensured from the very beginning. You can't really collect the data and then start worrying about the data quality. You got to worry about the data quality from the day one, that how your non-response rate will be, how people will respond to these questions. And then there is rule number 5, that statistical analysis is more than a set of computation. Please know this. It gives you comprehensive information about the phenomena that you are studying. It gives you an in-depth information about the phenomena that is under study. So you got to be very careful about it, that it's more than the set of computation. It gives you good insights. And then the rule 6 is keep it simple. I've talked about it earlier as well. So you want to keep it simple. You really don't need to go for the very complex statistical methodology. Instead, keep it as simple. Use a simple statistical methodology that can help you answer the question, and a layman can easily understand it as well. Rule number 7 says provide assessment of variability. Please know this: if you are reporting arithmetic mean should always be accompanied by the standard deviation or standard error of mean. You can't just simply report arithmetic mean. Likewise, when you are reporting percentage, numbers, frequencies, they are always should be accompanied by the percentages of the data. Similarly for other parameters as well. So you really gotta make sure that what you report and how you report. But knowing the variability is very important, because two different data sets can have same mean but different variability, different variances. So knowing the variance is always helpful, that help us to figure out that how much the variation is out there in the data. And then the rule number 8 is the check for assumption. A lot of time I've seen people do research, they run their statistical methods without checking for any assumption. So while you do this, please do check for your assumption in the model. And your statistical method, all the statistical methods comes with certain assumptions. If your assumptions are verified, they're good. That's the good way to move ahead. Rule number 9 is when possible, replicate. When possible, replicate your results, right? And rule number 10 is make your analysis reproducible. I've talked about both of the things earlier. And the last conclusion, the main core of the results section consists of text, tables, and graphs. Keep that in mind. Text provides narration and interpretation of the data presented, and tables are useful in summarizing large amounts of data systematically. Graphics should be used to highlight evidence and trends in the data presented, and the content of the data presented must match the research question and objective of the study in order to give meaning to your data presented. Otherwise, please try. There's always a temptation to give your own inputs, your own thoughts, and I've seen people always talk about these things. There's always a temptation. Please avoid that. If your data says so, talk about it. If your data doesn't say so, don't talk about it. And the most important conclusion is that keep the data and its statistical analysis as simple as possible to give the reader maximum clarity. So you gotta keep it simple as much as you can. And that's all from my side. Thank you so much. I'm open for the questions.
Thank you so much, sir. I will open this Zoom polling. You're all requested to please respond to that, and meanwhile, I will quickly move towards the comments and the questions. So we have question from Mr. Raja from Ziauddin University. It is also a common that if our results will not positive, then good journal will not publish it. Is it true?
Yes, it's true. I agree. I agree on that. A lot of journals, they also look for the positive results. But I personally think, and I'm of the school of thought that is of the view that negative results should be reported and they should be published. I do remember back in 2016, there was this psychology journal that says that if someone reports p-values, we are not going to publish the paper. Because as a statistician, I know that how much the p-value has been misused. And I've already talked about that people have tried, and just because of this fact that journals are reporting the positive results, people have tried to spin their results in a way that their negative results sounds positive. So, just being true to science that we do, as I said earlier, science is not about making people happy. Know this, journal editors are, are, are sometimes not scientists. Journal editors are like any other editor of a newspaper. They want to highlight the story. They want to highlight the story that can sell, because we are in a very vicious cycle of impact factors and you know, H index and all those things. And a impact factor will grow if a journal article is viewed more number of the time, if journal article is cited more number of the time. And usually what happens is the positive results are cited more number of the time than negative results. So, you know, it's extremely important that we fight against this norm, that negative results should be reported, and they should be discussed thoroughly. So I agree with your comment that journals won't publish that, but I personally think that negative results are equally important as compared to the positive results.
Thank you, sir. Next, we have Mohammad Siddiqui. He's saying that data tables and graph representing the same information. So what do you suggest when it is important to use both to represent the data, or when to skip graphs?
So when you, as I said earlier, that when you are talking about your main question, the key findings of your research that are like you think of like these are the key things that I can boast about these findings in my research. If you are able to have these kind of findings, you can report them in the text as well as in the table and graphs. That's fine, but try your best to report them in the it also depends upon the field you're writing. I mean, if I talk about the genetics, in genetics there are kind of like very fancy graphs out there, and people report their results in the graphs instead of reporting them in the tables. So you know, you can in that situation the graphs are important. In other situation, like if you're into the social sciences, over there people like to see more of the tables. So it depends upon the field of the research that you're coming from. It depends upon the norms in your field, that how people are reporting the result. But if you have the key finding, you can report them in more than one formats, but otherwise try to avoid reporting one finding in more than one format.
Thank you, sir. We have another two questions. We have another two questions and then a lot of comments. Mohammad Siddiqui again is asking, what is data manipulation and when to go for it?
Data manipulation. I mean, I do not know how one understands data manipulation. So data manipulation can be good and it can be bad. If I talk about data manipulation, then I talk about data cleaning. So when you are doing data cleaning, I would still call it data manipulation, but it's not that I'm changing the data. It's just I'm just changing the way I report the data, right? Like if you ask about, so I'll call this as a data manipulation, that I have age recorded in as a continuous variable, but I do not want to report it as a continuous variable. Instead, I want to report it as a categorical variable with the categories. So when I'm making the categories out of it, like less than 10, 10 to 20, 20 to 30, 30 to 40, 40 above. So these are the categories. I call this as a data manipulation. This type of data manipulation is fine. But if you say, oh, if you see an outlier that is 92 and you 92 years of age, and you try to make it, oh, well, it is 19, not 92. That is called, that kind of data manipulation is wrong. It's a crime. One should not change the original response of the respondent. So, you know, so it depends. And when you talk about the second kind of the data manipulation, I call it data fudging. It is you create your own data, and that's the wrong thing. You can't just, data cannot be just created while you do it on the computer. And I have seen a lot of people. I have actually met a number of people here in Lahore that they try to convince me that, oh, well, I have data, I've done this analysis, and my data is lost, but now I don't have the data with me, and use your expertise to help me reproduce the data. I can't do that. That's wrong. So if you don't have the data and you are showing me the results, 90% of the time I know this, some person has made up the results, and that's crime. That's a bad example, and one should not follow that. And if someone called this as a data manipulation, then this data manipulation is wrong. It's crime.
Thank you, sir. Moving on, we have Mr. Asadullah is asking, please suggest some basic regression practices that I can practice in MS Excel, Smart PLS, and SPSS, and some guidance about our software.
Some guidance about our software?
Yes, sir.
Well, that's like, well, for the R, you can certainly go to Coursera, Data Camp, a lot of online resources available out there. You can use that. Otherwise, I teach at FC College Stat 206. And if you're a student, you can certainly join that, that course. Then regarding SPSS regression on different softwares, I mean, you can use simple linear regression model and logistic regression model, and they're unlimited. I can't really talk about one or two. So if you really want to talk more about it, I can help you personally. So you can have my email and reach out to me. If you are from FC College, you can come to my office and I can help you with that.
I don't see any more questions, but we have a lot of comments. Outstanding presentation and explanation. Really enjoyed the session. Excellent session. You are a great teacher, Sir Asif Shami. Dr. Shabnam, excellent. Really interesting and informative session. We will be sharing the materials with you, the PowerPoint and the video recording with you within the next 3 to 5 working days. 10 rules are quite helpful. Dr. Shaista Ali from Government College University says, the write-up guidelines provided in this lecture are really helpful for researchers. Thanks, sir. Excellent session. I will be sharing the email address of Dr. Sharoon, so you can contact Hafiz Rukhsar. Very informative session we had. Thank you, sir. Amazing presentation, Dr. Sharoon. Dr. Rukhsana is here, ma'am. You want to contribute anything?
Sharoon, it's no surprise the chat is replete with commendations on the quality of the presentation and the substance. And it shows you're one of our best faculty at FCC, very, very accomplished in your discipline and of course statistics. We are very, very thankful to you for a great session, and we'll keep bothering you again and again. And thank you so much. And thank you everybody for being here. Okay, bye-bye.
Thank you so much.
Thank you all. Take care.
Thank you.
Bye.